In my last video, I showed you how to 3D print a Gridfinity organizer for spray bottles using the disposable bamboo filament cores. In that video, I also promised to show you how I modified the GridfinityGenerator to fit this project, and specifically how I reversed the Gridfinity screw hole directions in the base. Of course, this does run somewhat counter to my advice in my first Gridfinity video, where I specifically cautioned you to not edit the generator results, but rather let that add-on do all the work. However, I don't know of any place in that system where I see a direct way to reverse the screw holes in the Gridfinity base. Fortunately, it's easy, as I'll show you here. But before I do, I want to once again give credit to two people. First of all, Zach Friedman, who came up with the awesome Gridfinity organizer system, and Lev Mission, who programmed the incredible add-in called GridfinityGenerator. You can see all about that in my other video. I normally use my Fusion checklist for all my Fusion designs, but when using the GridfinityGenerator, it's not really needed. Additionally, I use parameters in my designs since that makes modifications very easy. But again, in this case, the generator takes care of all that, so I won't be doing that in this design. Now, let's take some measurements for the organizer. First of all, as you can see, 4 filament cords can fit on a bamboo printed build plate. I will remove the radio tag by lightly scoring the edges of the tag so I don't rip the core when I remove it. In case the core is not perfectly round, I'm going to take a couple of measurements. And it looks like the outer diameter is roughly 89 millimeters. That's what I'm going to use for the design. The thickness of the core is 3 millimeters. I want to waste as little space as possible on the organizer, but I do need a couple of millimeters at the outer perimeter for the bin to stay intact. Let's do some very simple math. We had a diameter of 89. There's obviously 2 next to each other, each direction. We have 2 edges of 2 millimeters each. Now the total is the 2 diameters and the 2 edges all combined. We get a total of 182 millimeters. I'm going to use 4 Gridfinity grids across each direction. So 182 divided by 4 equals 45.5 millimeters. It's time to open Fusion. Open the data panel and select the folder where you want to keep this design. Now close the data panel again and hit Control S and name and save the file. I will call it Spray Bottle Organizer. Open the bin generator. I'm assuming you already installed this. If not, you do need to go back and watch my other Gridfinity video. There's a link in the description. Let's start from the bottom of the designer. First, turn on visibility so we can see what we're doing. Next, go up the list to see what we need to change. We do not need a lip for stackability, and we do need a solid design. You can set the height of the bin right here in the designer. By default, it's set to 5 units, and each unit is 7 millimeters. As long as you're not in a numerical box, you can press I to check the measurements without losing your spot. In other words, you can set the height that you want in a combination of units and unit sizes. You can even choose fractional units as I'm showing here. Again, press I. Personally, I find it much easier to set the height units to 1 to have a solid bottom, and then extrude the surface to the exact height I want. I'll do that shortly. For now, let us finish the bin. I will set the length and width to the calculated 45.5 millimeters, and I'll set the X and Y bin units to 4. Now, I want you to notice something interesting. Notice that the dimensions here is 181.5 millimeter instead of 182 as we calculated. That's because I forgot about the clearance of 0.25 millimeter on both sides, adding up to half a millimeter. So I will only get 1.75 millimeter walls at the outer perimeter of the bin, which will be fine. This is a good time to save the project. I want the filament cores to be embedded into the plastic 12 millimeters or about half an inch. So I will extrude the top surface to that amount. Next, I will place a circle on the top surface. Obviously, I need 89 millimeter diameter. To place the circle, I need another quick calculation. We have a diameter of 89. The radius is half that. So 44 and a half. 2 millimeter edge, and then the clearance. So we take the radius plus the edge minus the clearance for a total of 46.25. Hit D for distance, and this 46.25 is the distance from the center to both edges. Next, make an inside offset, so negative offset of 3 millimeter, which is the thickness of the core. Now hit E to extrude the cylinder 12 millimeter into the bin, so negative 12 millimeter. This is the cutout for the filament core. Add a chamfer of half a millimeter to both cylinder edges so the core is easy to install. The rest of the cylinder cutouts are easy to make by using rectangular pattern. Make sure to select features and then select both extrusion and the chamfer in the timeline. Obviously, center to center distance in both directions is 89 millimeters, and we need 2 in each direction. The bin is done. Save your project. Hide the bin and open up the base generator. And we'll use the same procedure to set up the base starting at the bottom. Make the base visible. Check that the screw holes are added. Check the screw dimensions. The 3.2 and 6.2 millimeter size fits a number 5 flathead screw. You can leave the magnet holes in place. We are using the skeletonized base, and we need the X and Y units at 4, and finally set the width and length to our calculated 45.5 millimeters. Click OK and let the generator finish the base. It's important you save the project now since we're going to edit the design. This way you could go back to this point if you make a mistake. To reverse the screw direction, you need to look in the timeline for an extrusion followed by a chamfer. Then hover over the extrusion to see the name. You're looking for Simple Cylinder Extrude. Again, to be followed by a chamfer. Here it is. We need some information from the chamfer feature before we go on, so right-click on that and select Edit. Zoom in and rotate the base so you can confirm we are editing the correct feature. Indeed, this is the chamfer we need to move. Click OK or Cancel without doing anything to this. Now right-click the extrusion and select Edit. Delete the profile plane to get rid of the screw head extrusion. And then select the thin column as a new profile plane. Don't worry about the extra length, it will disappear. Now you see why we needed the chamfer info, as it is now missing its reference and shows a red arrow. Right-click the chamfer and select this other edge for the chamfer and enter the 1.5 millimeter. Click OK and inspect your whole design. We have reversed the screw hole and we have made a complete Gridfinity design with our own dimensions. Save your project and you can export it to your 3D printer. This video actually took longer than it takes to complete the whole project once you know what to do. I hope this helps you design your own Gridfinity organizers. If you do, please make sure to share them with all of us in case you get some clever ideas that we can all use. I will definitely share all my designs.